Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to discuss in detail about Snowflake architecture, and this is a very important video, and this video can be a little longer as well because we are going to discuss in depth about the Snowflake architecture. So stay tuned till the end of the video and do remember to like, share and subscribe to my channel. So moving ahead, talking about Snowflake architecture, right? When we talk about Snowflake architecture, words will not be just enough. So we have a lot of visuals to explain the Snowflake architecture as well. So when you talk about Snowflake architecture, it is a hybrid architecture. Remember that. It has both the qualities. So traditionally, whenever we talked about our, data warehouses, we had shared disk architecture or we had shared nothing architecture. Right, so when we talked about Teradata and all, right, in that case we had shared nothing database architecture, right? But when you talk about Snowflake, it has the mix of both, right? How does this my statement make sense to you? We will see the visual for that. So if you look at this particular visual, right, so when you look on the left hand side for the traditional architectures, right, shared disk, right, shared disk essentially means that your storage, right, where your data is stored is essentially shared, right? It is shared. And then you have clusters on top of it which are actually nothing but they give you compute power. So that is one of your traditional architecture. And the second architecture is a shared nothing architecture. Now in the shared nothing architecture, what happens is that your storage is decentralized, right? Now instead of just one shared storage, right, you have you just do not have just one shared storage, right? It is not like your shared disk architecture where your single disk is actually shared. So it becomes it becomes a really decentralized way, right? The shared nothing essentially becomes very decentralized because all your data is not just stored in one disk, right? And then you can have compute running on top of that disk. Now the point is this was the traditional architecture, but when you come to the Snowflake, right, now what happens over here? Now in the Snowflake, essentially data is shared, right? You have data shared at a centralized location, right? And you can scale out the storage as much as you want. You can scale out the storage, you can increase the storage, as much as you want. You have a centralized location for it, and then you have independent compute clusters or independent virtual warehouse that we call as it in terms of Snowflake. So you have independent compute clusters running on top of that centralized data storage. So that is why it is called as multi-cluster, because you have multiple clusters running, right, and trying to query the data. Multiple compute power, essentially you have that option, and that can also you can scale up that as well, right? And similarly you have the storage which can also be scaled out. So this essentially means that your Snowflake architecture is basically a hybrid of both shared disk as well as shared nothing database architectures. Now moving ahead, now similar to these shared disk architecture, right, I have already explained you, Snowflake uses centralized data repository. So it has a central data repository, right, where it stores the data, and this can be accessed, right, whenever you query it or whenever it requires, right, it can access the data from all the compute nodes in the platform because it has a multi-cluster architecture, right? And so this is related to your shared disk architecture, that you have a centralized data repository. Data repository is centralized. You have data stored at one place, but it can be scaled out, right? But when it comes to the shared nothing architecture, what we have talked about here, when it comes to shared nothing architecture, right, so what happens is Snowflake process queries using massive parallel processing, right, where each node in the cluster stores a portion of entire data set locally. So essentially what it will do, it will actually help you to increase the performance, because now at this time what is happening is you have compute clusters, right? You have compute clusters which are actually running on top of your centralized repository. So this essentially is, a very small introduction of your Databricks architecture, but we have a lot right now. So don't worry with that. Even if you did not understand it, you can watch the video twice and we have a lot of, data points coming in. So this picture also, explains you that it has a centralized storage, right? When you talk about the architecture, now architecture will come with the 3 layers, right? I already told you it has storage layer, right? It stores the data in the centralized location, and then you have a compute layer, right? Now first layer is the storage layer, and then you have a compute layer, right, which is nothing but it is actually used for the development, your loading, your querying, and then it has a service layer which is nothing but the services offered by your Snowflake, right? So 3 layers comes along with that: storage, compute, and service. Now this video also, this image also gives you little in depth about this architecture. So at the bottom, right, you have the storage layer, right? It is a scalable storage, right, as mentioned over here. Scalable as in it can get increased, right? If you want to increase, you can scale it out, right? We will talk about what does this hybrid columnar mean. We will talk about it in detail. And on top of this storage, you have virtual warehouse as well. Now this virtual warehouse is nothing but the compute power, right? This virtual warehouse is nothing but the compute power, the clusters, you can say, right, which are used to, query your data from here, right? And they can also store a local copy of your data at the compute node. In this virtual warehouse itself, they can actually store a copy of your data in form of cache as well. Remember that it can store a copy of your data. It actually, this is very beneficial. We can talk about it later because we have a lot of other videos as well. I'll discuss about it. So when you query, let's say when you fire select star from let's say any XYZ table where using a where clause, and then you run the same query again in Snowflake, right? What will happen is the second time when you run this query will run very fast, right? So these are the small things that are really helpful, and essentially we will talk about all those in details, so no worries about that. Also, after this virtual warehouse, you can also see these the service layer essentially, right? The service layer where you can manage the security, where you can manage the metadata, your authentication related things you can manage in this service layer itself, right? And you can host it in any cloud. You can host it in Azure, you can host it in AWS or GCP, right? And when I now this is just a reflection of how the architecture can look like when it comes to Azure or AWS. So let's see about Azure. Now what happens is, let's say you have your Snowflake set it up here. Now if you see, whenever you are trying to do any query, right, a load balancer is associated, right? You have your query is actually very much load balanced. Now you have the load balancer, then you have all your cloud services running behind, you have your metadata stored behind, you have your virtual warehouses, which is nothing but your Azure virtual machine. So now when you move it to Azure, it becomes your virtual warehouses are nothing but your Azure virtual machines, right? Compute instances, compute power. And it is in turn, it is also linked to your blob storage, right? Azure blob storage, about which we have talked, right? So for any kind of data store, it actually uses Azure blob storage beneath. Similarly, coming on to the Amazon side of it, you have the load balancer, which is common, you have the cloud services, you have the meta store. Now here the virtual warehouses becomes the EC2 instances, right? In case of Azure, it is Azure VM, and in case of your Amazon, it is EC2 instances. And then of course you have your S3 storage in case of AWS. Now this again represents the same thing, right? I'm showing you diagrammatically so that it is even more convenient to understand. But yeah, now we will discuss in detail about the database storage, right? Now what kind of storage, we will talk about how the data is stored in Snowflake. Now Remember that whenever you load the data into Snowflake, right, it compresses that data internally. It compresses the data, it optimizes the data when you store it in the Snowflake. It reorganizes your data to compress it, and it compresses it in a columnar format, right? So this is nothing but optimized data that is actually stored in your Snowflake by default, and Snowflake manages it. You don't have to do anything, right? The file size, the structure, the compression, the metadata, the statistics, everything is handled by the Snowflake itself. You have to do nothing, and you don't even know about it, right, until we are discussing in this video. So, and whatever the data objects are stored by Snowflake, they are not directly visible, right, or nor they can be accessed by the customers, right? You can only get the data when you're trying to do a SQL operation, right? And then we will discuss in detail about the micro partition. So whenever you store any data in the tables, right, what exactly happens? Whenever you store your data in the Snowflake, it gets stored in form of micro partitions, right? It gets converted in the form of micro partition, right? And in fact, let me show you, that will be much better rather than me explaining it. So if you look at this particular diagram over here, what is essentially happening? This blue box over here, it is nothing but the data, right? You have your ID column over here. Let's say you have your name, country and date, right? So the moment you add this data into any table, the physical structure of micro partitions will look something like this, right? So row 1 to 6 will come over here, right? It gets stored in a columnar format. So ID column is stored over here, name column is stored over here. So corresponding to ID 4, your name is C, right? Your country is SP, right? Your date is 11/2, right? So this is how your data gets stored at the micro partition level, right? It is also called as FDN, right? So you should always remember that this essentially happens. Now, since the data is stored in columnar structure, we have already talked about Parquet files, if I'm not wrong, in one of my videos, right? So Parquet files, why they are better, right? Because the data is compressed, it is in columnar format, right? And it is very easier to fire read queries on columnar data structure, right? So compression is good and it becomes really very efficient. So that is the use of your micro partitions whenever data is stored in Snowflake, right? And these micro partition or FDNs, they are same meaning, they are the same thing, right? So micro partitions or FDNs, they are immutable. So what essentially it means that, so for example, you add a new row, right? What will happen is it will add your new row to the micro partition, and let's say you delete the older row, right? It is not going to completely delete your FDN, right? It is not going to completely delete your FDN because it is going to retain your micro partition. It is going to retain your micro partition, and that is why Snowflake is also has version controlling. It also has time travel. So just like Databricks, right, it has Databricks Delta tables, it also has versioning and time travel. We will do it later, right? So versioning means, let's say I delete by mistake, I run a truncate statement, and then I want to retrieve the data. Can I do that? Yes, I can do that, because the micro partitions in which the data is being stored in Snowflake, that micro partition is not mutable. It cannot be changed. What happens is the latest micro partition comes up, right? The latest micro partition, the latest insert, updates or deletes are reflected in the final state, but the old state is not deleted, right? Also, these micro partition, right, they also have metadata stored, right? So we'll talk about this metadata as well. So Snowflake, what it does is automatically it collects and stores the statistics of a table and micro partition column level, whenever you ingest the data into any table. So what does this mean? It tries to analyze that what are the number of rows, what is the size of your table. So these kind of micro details or the statistical details of your table, or things like what is the minimum and the maximum value, what is the average value, how many nulls are present, how many distinct values are present. So all these details, right, are captured. All this is also called your statistics, right? All these statistics are actually captured by Snowflake, right? And all these details, right, whenever you add the data into the table, that time itself it gets created. So it does not have any separate job, right, to store your statistical information, right? And this particular diagram shows you how micro partitions looks like, right? And coming on to the query processing, right, because the first was the storage layer, the second layer is nothing but your compute, right, your virtual warehouses, your query processing. Now query processing, already explained, right, what it is nothing but it processes the queries whatever you fire in the front end, right? It using the virtual warehouses, using the virtual machines, right? What it tries to do, it just tries to query your data which is present, right? And we have already talked about it. Now coming on to this virtual warehouses as well, right? If you remember this virtual warehouse, right, it is nothing but virtual machines. So this is nothing but a logical collection of virtual machines which are grouped together in a cluster. So that is called your virtual warehouse, and this virtual warehouse is actually used to query your data which is present in the centralized location. And the configuration of the VM, right, that is also mentioned in this slide. AWS, you can actually see the whole configuration for the AWS. For Azure, you can actually see the whole configuration, right? It uses SSD, right? Right now everything is in SSD although. So 28 GB of memory, 400 GB SSD, you have it in Azure. And similarly, now this configuration might change, it's not like Snowflake might come up with updations and all, so don't take it as the hard word. So this part can get changed as Snowflake updates. Also remember that you can, whenever you are trying to run a query, just like you select a cluster in the Databricks, in the similar way you actually select the warehouse as well in your Snowflake, right? And when you select that warehouse, we will actually see it in our videos as well, in our upcoming videos, the size of your cluster, right? You have to choose the size of the cluster, and the size of the cluster essentially means the number of nodes, right? The number of compute clusters, the number of nodes, right? So that you have to choose it from XS, S, you have XL, 2XL, 3XL, like that you have the list, right? So more complicated your query gets, you can increase the compute power as well, right? And this virtual warehouse, they will always help you, for any temporary storage, right? They will help you for your CPU requirements whenever you want to run a query, whenever you want to execute a SQL statement, right? Whenever you want to perform any data manipulation operations, you want to do a delete, insert, update, right? You want to do copy into table, right? So copy into is essentially for Snowflake only, right? You don't use it in SQL. So there is a difference in the language as well, right? It is not pure SQL, right? There are differences, because few things direct from SQL will not work in Snowflake. Remember that, because Snowflake does not enforce primary and foreign keys. We'll talk about that later. Let it be. Let us not talk about it in this video. Now, many operations in Snowflake are serviced by global services metadata. Now, what is this? I exactly talked about it a minute back, right? So you have statistics, right, which gets captured whenever you insert the data into a table. So what happens is, whenever you're trying to query your data, select maximum value from this, select minimum value from this, right? So all this data, what happens is, metadata is already stored by Snowflake, so it will not directly query your data. So in turn, what will happen is, since it is using your cached data, it is using your metadata, it is using your statistics data, what will happen is it is not going to directly query your data, right? So your query returns, your timing for each of your query will be pretty faster. Now this is again a diagrammatical representation. So whenever you fire a SQL query, you need to select what kind of warehouse you want to, what size of warehouse you want to run your query on. So in case your query is complex, you can increase the number of compute nodes, from 2xs to XS, like that. Then you have Excel, then you have you have medium in between, then you have Excel, then you have double Excel, something like that. You have all the ranges available, right? We will see it when it comes, right? Whenever we'll do hands-on, we will do this as well. Now remember that the scale out for concurrency. So in virtual warehouses, see, the number of compute nodes you are increasing by choosing the size over here, right? Excel, small and all, right? Now you are actually what you are trying to do over here, you are trying to increase the number of compute nodes. Now the cluster, right? What happens is, whenever you are trying to query, whenever multiple users are trying to query Snowflake, what happens is, if there are like more than one user which are concurrently working, then what happens is it automatically increases the number of clusters based on the concurrent usage, right? It adds and it removes as well. It allocates and deallocates clusters whenever multiple users are trying to query as well, because it has multi-cluster, it is a multi-cluster warehouse, right? And all the queries are load balanced. And what happens is, if one cluster is running, right, and one user is querying, it will not affect, right, the data or the query speed of the second user, right? So these are the very good features that you have in Snowflake. And also warehouse sizing. So if you see over here, right, now I have told you that this is how you can actually increase the warehouse size, right? XS, S, M, L, XL, 2XL, 3XL and 4XL, right? This is how you can increase. By increasing it, you are essentially increasing the number of compute nodes. And scale for concurrency, right? So when you try to run concurrently, right, then again you can actually scale it, right? And now what happens over here? So what you see in the middle, right, this is nothing but the cost, right? It is nothing but the cost associated, right? The number of credits utilized per hour whenever you choose this configuration. So for XS and let's say for XS and concurrency is 3, right? For per hour you are going to give 3 credits. So this is how your warehouse sizing also works in Snowflake. Now similarly, cloud services, this is pretty simple, right? So whenever all these services, when they come together in Snowflake and it is provided to you as a user, what essentially happens is you need to authenticate, right? So all you need to authenticate, you need to manage infrastructure, although most of the things are already managed by Snowflake, but still a little bit work is still there. So infrastructure management is there, you have little bit of like this metadata management as well. Similarly, these services are very well provided by Snowflake, right? How to provide the access, I will actually show you this access part as well, but this access control part is also very well provided by Snowflake, where you can go and add a role, and you can add a user to that role, and you can actually see the only a user with a specific role will be actually able to see the data, right? So all these cloud services, this comes under the cloud service layer of Snowflake, right? And we can we will actually go through when we open the UI for Snowflake as well. We will go through all of these in detail, right? So these services comes on top of your compute layer, right, that we discussed. On top of your virtual warehouse it comes, and we will actually see that how we can actually use it. So let me know in the comment section if you have any doubt. In case you did not understand it, no worries, we have a lot of videos coming in. And do remember to like, share and subscribe, and rerun this video in case you did not understand in one go, because yes, this included a lot of information in one go, because I kind of don't believe in making short videos. So I try to cover most of the content related to one topic in a video, but that's why it became little longer. But I hope you still liked it, and thank you so much for supporting me, and keep watching. Thank you.